Hello students, welcome to Infotech Pathshala. In this video, you will learn decimal to hexadecimal conversion and hexadecimal to decimal conversion. So let's start. First, I would like to explain binary representation of hexadecimal numbers and decimal numbers. So as you can see on the screen, there is a table given where decimal numbers and their equivalent binary number and hexadecimal numbers are given. So 0 is equal to 0000 and its hexadecimal equivalent is 0, and 1 is 0001 and its hexadecimal equivalent is 1, and 2 is equal to 0010 and its hexadecimal equivalent is 2. 3 is 0011 and its hexadecimal equivalent is 3, and 4 is equal to 0100 and its hexadecimal equivalent is 4. 5 is equal to 0101 and its hexadecimal equivalent is 5. Now 6 is equal to 0110 and its hexadecimal equivalent is 6. Now 7 is equal to 0111 and its hexadecimal equivalent is 7. Now 8 is equal to 1000 and its hexadecimal equivalent is 8. Now 9 is equal to 1001 and its hexadecimal equivalent is 9. Now 10 is equal to 1010 and its hexadecimal equivalent is A. Why? Because when we will write 10, it would be difficult for us to identify whether it is 1 or 0. So double digit numbers will be identified by an alphabet. So 10 will be identified as A. 11 will be identified as B and its binary equivalent is 1011, and 12 will be identified as C and its binary equivalent is 1100. 13 will be identified as D and its binary equivalent is 1101. 14 is E and its binary equivalent is 1110. 15 is F and its binary equivalent is 4 times 1s. Now come to decimal to hexadecimal conversion. So as you are aware, the base of decimal number system is 10 and the base of the hexadecimal number system is 16, and this is the way to represent a decimal number and a hexadecimal number. We have to subscript the base. Now we want to convert 673 into hexadecimal, so we will divide this number by 16 till we get the quotient less than 16. So we will write 673 over here, and this number will be divided by 16, and it would be 16 fours are 64, and the remainder is 3, and this will become 3 and 3 33, and 16 twos are 32 and the remainder is 1, and 16 we are writing quotient over here and remainder over here. Now this 42 will be divided by 16 again, so 16 twos are 32 and the remainder is 10. Now this 2 cannot be further divided by 16 because it is less than 16, so this will be considered as it is and it will be treated as MSD, that is most significant digit, and this first remainder would be treated as LSD, that is least significant digit. So to convert decimal number into hexadecimal number, we have to move from bottom to top. So to get the hexadecimal equivalent of the given decimal number, we have to move from bottom to top. But as you can see, there is a 10 and 10 is identified by A. So this would be 2A1. So the hexadecimal equivalent of the given decimal number is 2A1. Okay, now come to decimal to hexadecimal conversion with the float number. If a decimal number is given with a decimal part, so we'll take its integer part first and we'll take its decimal part another way. So integer part conversion we have just learned. So the same way we will convert its integer part into hexadecimal. So this number will be divided by 16 till we get the quotient less than 16. So it will be 339 and the remainder is 13. Again it will be divided by 16, so we will get 16 twos are 32 and then 16 ones are 16 and the remainder is 3 in this way, and again this 21 will be divided by 16, so we'll get 16 ones are 16 and the remainder is 5. Now this 1 cannot be further divided by 16 because it is less than 16. So we'll take 1 as it is. So 1 is the MSD and 13 is the LSD, that is least significant digit and most significant digit, and 13 is identified by D, capital D. So moving from bottom to top, we will get 1 5 3 D. So this is the hexadecimal equivalent of 5437. Okay, now come to its decimal part. Now decimal part is 0.35. So 0.35 will be multiplied by 16 and we will take its integer part as the hexadecimal equivalent. Okay, so the answer is 5.6. So 5 will be considered. So 5 will take, and 0.6 will be again multiplied by 16. 0.6 multiplied by 16 and we will get 9.6. Its integer part is 9, so we'll take its integer part and we will multiply its decimal part again by 16. So we will get 9.6 again. So again in this way integer part is 9. Now after decimal only 3 digits are sufficient. You can multiply its fractional part further. Okay, now to convert the decimal part into hexadecimal, we will move from top to bottom, not from bottom to top. So we will get 0.599 as the hexadecimal equivalent of 0.35. So the answer would be 153D 0.599. This is the hexadecimal equivalent of 5437.35. Now come to hexadecimal to decimal conversion. So before explaining hexadecimal to decimal conversion, I would like to explain place value chart for a decimal number. As you can see on the screen, 926 is given and the place value of 6 is unit position, that means on ones, and the place value of 2 is on tens and the place value of 9 is on 100. Now this 6 can be written as 6 multiplied by 10 raised to power 0, and which is equals to 6 multiplied by 1 means equal to 6, and 2 can be written as 2 multiplied by 10 raised to power 1, which is equals to 2 multiplied by 10, which is equals to 20. 9 is equal to 10 raised to power 2 is equal to 9 multiplied by 100, which is equals to 900. So when we will add these numbers, we will get 926. So in this way a decimal number can be expanded. Now as we are using decimal number system, so that's why we have taken base 10. So when we will convert a hexadecimal number into decimal, we will take base as 16. So the number is given 6AC and C is equal to 12, A is equal to 10. So the C will be multiplied by 16 raised to power 0 plus this A will be multiplied by 16 raised to power 1 plus this 6 will be multiplied by 16 raised to power 2. Okay, now this 16 raised to power 2 is equal to 256. So this 6 will be multiplied by 2 raised to 256 plus 16 raised to power 1 is equal to 16. So this 10 will be multiplied by 16 plus 12 will be multiplied by the 16 raised to power 0, which is equals to 1. So this will be 1536 plus this is 160 and this is 12. So the result is, when we will add these three numbers, we will get 1708. So 1708 is the decimal equivalent of the given hexadecimal number 1708. Now come to hexadecimal to decimal conversion with a float number. Means when a decimal part is there of hexadecimal number, so whenever we move towards right of the decimal point, we multiply the number by 2. 16 raised to power minus 1, 16 raised to power minus 2, 16 raised to power minus 3, and so on. And when we move towards left of the decimal point, we multiply the number by 16 raised to power 0, 16 raised to power 1, 16 raised to power 2, 16 raised to power 3, and so on. And the numbers is E4A.75. So this A, as you are aware, A is identified by 10. I mean, equivalent number is 10, and this will be multiplied by 16 raised to power 0, plus 4 will be multiplied by 16 raised to power 1, plus E means 14 will be multiplied by 16 raised to power 2. Okay, and this 7 will be multiplied by 16 raised to power minus 1, plus 5 will be multiplied by 16 raised to power minus 2. Now this 14 will be multiplied by 256, because 16 raised to power 2 is equal to 256, and 4 will be multiplied by 16, because 16 raised to power 1 is 16, and this 10 will be multiplied by 1, because 16 raised to power 0 is equal to 1. Now this is the 4. Okay, plus 7 will be multiplied by 1 upon 16, plus 5 multiplied by 1 upon 16 raised to power 2. Now when we will multiply these numbers, we will get 3584 plus 64 plus 10, and this will be 7 divided by 16 plus 5 divided by 64. So these, after adding these three numbers, we will get 3658 plus, this can be written as 0.4375 plus 0.0195. So when we will add these numbers, we will get 3658.457. So this is the decimal equivalent of the given hexadecimal number. So answer is 3658.457. I hope you all have understood. Thank you.